Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 21 video on the chapter of measures of central tendency, where I will be discussing the final topic, which is mode of how to find the mode of a group data. The group data could be continuous or discontinuous. So this video is part of the playlist CBSE Maths for class 9 following the textbook of author RD Sharma. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so how do we find the mode of a group data? That is, we are given classes. We are given classes and their frequencies. The class could be given either in the exclusive form, which is continuous, or in inclusive form, which is discontinuous. Now, the first step is that we have to convert the classes, given classes of the group data, into exclusive or continuous form if they are given in inclusive or discontinuous form. For example, you can see on the left hand side, we have a discontinuous classes. Why discontinuous classes? We see that the upper limit of any class is not equal to the lower limit of the next class. So that's why it is discontinuous. So first we have to convert it to convert all the classes into continuous or exclusive form. How do we do that? We will see that the difference between the upper limit of any class interval is equal and the lower limit of the next class is equal to 1. So that 1, if d is the difference, between the upper limit of any class and the lower limit of the next class, then you find d by 2, and then for all classes you subtract d by 2 from the lower limit. That is, the lower limit becomes L minus d by 2, and you add d by 2 to the upper limit. So upper limit becomes u plus d by 2. In this example, you can see d is equal to 1. So we are subtracting and adding 1 by 2, that is 0.5 from the lower limit from in all the classes. We are subtracting 0.5 from the lower limit of all the classes, and we are adding 0.5 to the upper limit of all the classes, and then the classes will become continuous or exclusive form, where you will see that the upper limit of any class is equal to the lower limit of the next class. Okay, so this was step 1, and then step 2 is to find the modal class. What is the modal? Which class is the modal? The classes from all the continuous classes, or from the continuous classes, the class having the maximum frequency is the modal class. So we find the modal class, and from the modal class we find the lower limit. Actually, this will not be L1 but L, capital L. So let capital L be the lower limit of the modal class, f small f be the frequency of the modal class, f1 is the frequency of class previous to the modal class, f2 is the frequency of class next to the modal class, c is the width or size of the modal class, and then we find all these parameters, and then finally we compute the mean using this formula. That mode will be equal to, it will be L plus f minus f1 multiplied by c divided by twice f minus f1 plus f2. C is the width or class of the modal class, L is the lower limit of the modal class, small f is the frequency of the modal class, f1 is the frequency of the class previous to the modal class, and f2 is the frequency of the class next to the modal class. You have to remember this formula. Now let's solve apply this concept to solve two problems. In the first problem, we have to find the mode of the following distribution. We can see the class intervals given are in the inclusive form, that is discontinuous, because we see that the upper limit of any class is not equal to the lower limit of the next class, and we see there is a difference of 1. between the upper limit of any class and the lower limit of the next class. So for this, we have to first convert the class intervals to a continuous or exclusive form. So we see here a d is equal to 1. So d by 2 will be equal to 0.5. So let's this will be we say exclusive class interval, exclusive class in exclusive class intervals will be, then we subtract 0.5 from all the lower limits and we add 0.5 to all the upper limits. So this becomes 0.5 to 19.5. Then we have 19.5 to 39.5, 39.5 to 59.5, 59.5 to 79.5, and finally 79.5 to 99.5. Okay. Now we identify what will be the modal class. We see the frequency column and locate the maximum frequency, which is 23. So the class interval corresponding to the maximum frequency will be the modal class, which will be 39.5 to 59.5. So modal class, remember the modal class will be you have to once from the exclusive class intervals that we have converted from the inclusive class intervals. So modal class is 39.5 to 59.5. So this implies once we know the modal class, we know the lower limit will be 39.5. We know the small f, that is the frequency corresponding to the modal class, which is 23. We know f1, frequency of the class previous to the modal class, which will be 20, and frequency of the class next to the modal class, which will be 22. And of course c is the width of the modal class, which is lower limit minus upper limit minus lower limit, which is 20. So now mode will be equal to L plus f minus f1 multiplied by c divided by twice of f minus f1 plus f2. Okay. This will be L is 39.5, f was 20, f was 23, f1 is 20, and c is 20 divided by twice of f, 2 into 23 minus f1 plus f2, that is 20 plus 22. Okay. This is equal to 39.5 plus 23 minus 3 is 3 into 20, 60 divided by whatever we have 46 minus 44, which is 2. So this is equal to maybe I have done something wrong. The answer is 54.5. 30. What is the maximum frequency is 23. So the modal class is 39.5 to 59.5. Okay. C is 20. Okay. F2 is 22. F1 is 22. Okay. F1 is 20. C is 20. So 23 minus 20 is 3. 3 into 20 is 60. 60 divided by, we have 23 into 2 is 46 minus 42. So this will be 4. Sorry, this will be 4. This will be 4. So this is basically 39.5 plus 15, which is 54.5. So the mode is 54.5. Okay, let's see the next problem. So in this problem, the given class interval, given class intervals were not were discontinuous or inclusive. Okay, let's see the next problem. Find mode of the following distribution. In this example, the class intervals we can see are all continuous. That is, the upper limit of all the classes is equal to the lower limit of the next class. Okay, so we just need to, then we do not need to create the exclusive class intervals, because the given class intervals are already the exclusive form or continuous. So we see the maximum frequency is 9. Okay, so we see, so the model class is the class corresponding to the maximum frequency, which is 30 to 40. So this implies lower limit of the model class is 30 if maximum frequency is 9, if 1 will be the frequency of the class previous to the model class. So this is the model class, frequency of the class previous to the model class, which is 3, and if 2 will be frequency of the class interval next to the model class, which is 5. So this is F1 and this is F2. And what is C? C is the width or class of the model class, which will be upper limit minus lower limit of the model class, which is 40 minus 30, which is equal to 10. So now we can easily find the mode to be equal to L plus F minus F1 multiplied by C divided by twice F minus F1 plus F2. This is equal to L is 30 plus F is 9. 9 minus 3 multiplied by C is 10 divided by twice 9 minus F1 plus F2, which is 3 plus 5. This becomes 30 plus 9 minus 3 is 6, 60 divided by 9 multiplied by 2 is 18, 18 minus 8 is 10. So this is 36. So the mode is 36. So that is all for regarding the finding how do we find the mode of a group data. The only thing is that if the class intervals of the given group data are not continuous, then you have to first convert them to the continuous or exclusive form by using the by calculating the difference of the upper limit and the lower limit of the upper limit of any class and the lower limit of the next class. If that difference is d, then subtract all the lower limits by d by 2 and add d by 2 to all the upper limits. That will give the class intervals in continuous form. And then we find the model class, that is the class corresponding to the having the maximum frequency, the continuous class that is having the maximum frequency. That maximum frequency is small f, and then L, capital L is the lower limit of the model class. F1 is the frequency of the class interval previous to the model class. F2 is the frequency of the class interval next to the model class, and then we using this formula we calculate the mode. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I think probably I will make one or two more videos in for solving problems based on all the concepts from the chapter of measures of central tendency. so that you have a final revision of the chapter, and then I will move on to the another chapter. It could be tabular representation of data. So please stay tuned for these videos to come. I'm ending the video here. Thanks for watching, and until the next video, take care and bye.